Here we'll do another example with compound interest. This question says, if an investment account contains $2,000 initially and is compounded quarterly with an interest rate of 3%, how many years will it take to reach $2,400 in the account? We can see that it is compounded quarterly, so once again, we'll write our compound interest formula. That formula says that y is equal to p times 1 plus r over n, all raised to the n times t. Let's have a look at the passage and see which letters we know. We are given that we have $2,000 initially. Our initial investment is P for principal. We'll write that down. We are also told it's compounded quarterly. The number of times we're going to compound per year is n, but quarterly means 4. Much like how there are 4 quarters in a dollar. We also have an interest rate given to us of 3%. That will be our R. So we'll say R is equal to 0.03 since we must use decimal form. And we are also given that we want to reach $2,400 in the account. The $2,400 is our new amount of money, and our new amount of money is in fact the Y. So we'll say Y is 2,400. Let's go back to the formula and check off what we know. We know the Y, the P, the R, and the N. However, we don't know the T. Therefore, our unknown will be T, and we're going to try to get T by itself. First, let's plug in what we do know. Y is 2,400. That's equal to 2,000 times 1 plus R over N, where R is 0.03 and N is 4. This is going to be raised to N times T. The N is 4 and the T is unknown. Now that we've set up our formula, we can see that our unknown is inside of an exponential. When your unknown is inside of an exponential, we can use a logarithm to find its value. However, it's not the best time to take a logarithm right yet. Before you take a logarithm, try to get the exponential by itself on the right. Therefore, we're going to have to divide by 2,000 in order to get that exponential by itself. If we do that division, we'll end up with 1.2 on the left equal to 1 plus 0.03 over 4 on the right. We can simplify the 1 plus 0.03 over 4 into a decimal number first. If we add that together, we will get 1.0075. This will be raised to the 4t. So now on the left we have a single number, and on the right we have just our exponential. Now I'll show you how to use logarithms to find that unknown t. Now that we have this exponential on the right by itself, we'll take a log on both sides. I'll write log and leave an open parentheses on the left, and I'll do the same on the right. On the left, I'll take the 1.2 and place it in the first parentheses. On the right, I'll do the same with this exponential. Now that I've taken the logarithm on both sides, that's going to make it easier to solve for t. There's a special rule that we can apply to logarithms that have exponents. Anytime you have a logarithm with an exponent, you can move the exponent down in front of the logarithm and then multiply. You can visualize this as taking the 4t out of the exponent and just putting it in front of that log 1.0075. So on the left we will still have log of 1.2, and on the right we now have 4t times log of 1.0075. Now we can just divide to get the t by itself, since that's what we're still solving for. Anything that is still multiplied by t, we can divide by. Therefore, on the right, we will divide by 4 log 1.0075, and we'll divide by the same on the left. This means the 4 and the log on the right will cancel, leaving us only with t. On the left, we now have log of 1.2 divided by 4 times log of 1.0075. Now we can just do the arithmetic in a calculator and we'll get the value for t. When we divide, we get 6.1. This tells us that it would take 6.1 years to reach a total of $2,400. The takeaway here is that anytime we have an unknown in an exponent, we can take a logarithm, move the exponent down, and then solve for the letter that we're after.